Is my screen visible to all of you?
Yes, sir.
Okay, thank you. And this one as well, right? It's visible.
Yes, sir.
Okay, thank you. All right. With a brief introduction of myself, Dr. Saroj Kumar Patra, Assistant Professor of Physics at MPC Autonomous College, Baripada. Uh, I will be counseling on Quantum 2 paper. I expect all the participants have already covered Quantum 1. Uh, for example, basic mathematical formulation of quantum mechanics and hydrogen atom, one-dimensional problems, right? So today we'll start something for the intermediate quantum mechanics or quantum 2. Uh, so I'll be sharing my screen where I have the material provided by IGNO. I guess all of you have that uh, PDF or printout. I would prefer every participant to have a printout of or the book format, hard copy format of the book, the material. Uh, so in between, I will be switching between the screen and the video, where if I have to write something, then I will be using that. Is that fine?
Yes, sir.
Okay. Just for a small query, is it okay to speak in Odia or Hindi or English? Which one is more preferred?
English will be preferred, sir.
Okay, fine. Then if somebody have problem, you can ask question in Hindi and Odia as well. I'll
Yes, yes,
try.
sir. Sure,
Yeah.
sir, sure.
So yeah, fine. So this is what we'll be starting. Symmetry in quantum mechanics 1 and symmetry in quantum mechanics 2, then identical particles and addition of angular momentum. Uh, Starting with unit 1, which is the symmetry in quantum mechanics. So here we'll try to focus on space translation, rotation, time translation, and conservation laws. So basically the symmetry problems, or how symmetry can lead to conservation laws. That is the idea of this unit. Everybody has this PDF or printout with you right now? I would suggest all of you to open that uh, PDF or the book, printed book. So here comes the introduction. Uh, as it says, we have studied little bit of classical mechanics and mathematical formulation of quantum mechanics, and based on that, we'll now try to see how quantum mechanics affects other formulation of physics. Uh, so symmetry is one of the very interesting topic So what is symmetry? Symmetry operation on any system can be defined as an action or a change on a physical system that leaves the system invariant. That means what happens? You do the symmetry operation and the system does not change. A classic example would be translation. If I try to explain that if one event translates, suppose you are conducting an experiment, um, let's say refractive index measurement by a prism, using a prism, and you are doing this experiment, let's say in Bhubaneswar, and suddenly you transfer it to Calcutta, then the results will not change. So this is translational symmetry where the physics will not change. So any such kind of operations, because it could be translation, rotation, any other kind of operation. So a symmetry operation on any system can be defined as an action on a physical system that leaves the system invariant. That means if we are describing the system by an wave function psi, which you have already done in quantum 1, then the psi should not change. The psi before symmetry operation and psi after symmetry operation must be same. So that's why the example is given that, for example, if the force acting on the physical system does not depend upon the location of the system, the force does not has a position dependent part, then the result of the experiment on the system would be same irrespective of which origin of space of experiment is carried out. As I said, if you are doing a refractive index measurement by using a prism, if you are doing it in Bhubaneswar or you are doing it in Calcutta, the result would be same unless the forces affecting the experiment are not position dependent. So this is an example of translational symmetry, a consequence of homogeneity of space. This is important. This is a consequence of homogeneity of space leads to the conservation of linear momentum. We'll see how the translational symmetry leads to the conservation of linear momentum. Now, if you have, as in quantum 1, you already have uh, discussed that physical quantities can be represented by an operator, right? So you have position operator, momentum operator, energy operator. So all physical quantities can be represented by an operator. So I believe all of you are familiar with this kind of equation, right? Like here, right? Everybody familiar with this equation?
Yes.
Yeah. Okay. So this is basically giving you an expectation value or the measured value. So when you do an experiment and you are measuring something in a quantum system, the expectation value is the value which you generally get in an experimental result. So how exactly you define psi a psi bracket? Then this is coming because your phi, the eigen get can be psi can be expressed in terms of basis of phi. So psi will be equal to summation ai phi I. So that's why in a Bragg vector you can actually write it like this. So the result of the measurement depends on the transition amplitude between quantum state, and therefore the symmetry transformation on quantum system is one that leaves the transition amplitude between the two states unchanged. So basically you are operating on a system psi, so it is going from one state to other state, the translated state. So what exactly, let us try to focus what exactly we'll be getting out of this unit. So the space translation operator for infinitesimal and finite space translation and be able to establish the properties. The linear momentum is the generator of space translation, and the matrix representation for rotational operation or rotation operator, and then the angular momentum is the generator of rotation. So these parts are quite this is also very important to remember that linear momentum is the generator of space translation. We'll see the mathematics as well. Angular momentum is the generator of rotation, and here also time translation operator, yeah, so which will give rise to your Hamiltonian and conservation of energy. So space translation, let us come to space translation. What do we mean by space translation? So basically, we are changing the position. We are changing, suppose we are at point R, which is given by three Cartesian coordinates x, y, and z. So then, in quantum mechanics, we have to every all physical quantities are represented by an operator. So if we represent it by a position operator, which is basically our uh, position operator x cap, uh, and in terms of bracket notation, the state is represented as psi vector or psi cat. So in that case, psi r will be equal to the bracket r psi, which this is nothing but representing that we are at position r vector operating on, or position vector operating on psi. So in one dimension it is psi x will be equal to x psi bracket, and in case of three dimension we'll have psi r will be equal to r psi, where r is the position vector. Now, what about the commutation relation? Uh, all of you familiar with the commutation relation given here? Is this equation familiar to you? It's from previous quantum paper. Is it clear? This relation familiar to you? It is समझते जानी था? So this is nothing but, so let me remind little bit, coming back to my notes. So if I write it, uh, a cap b cap, this is nothing but ab minus ba. So when we write this equal to, if I am writing a b operator is equal to 0, that means what I mean is a cap b cap operating on psi must be equal to b cap a cap operating on psi. Is this clear?
Yes, sir.
Right. Is there any problem up to this point? Or you can ask me. That's fine, because it should be a two-way round. It's counseling. It's not like one-way lecturing. So you can in between stop me and ask me to have some issue. Is that fine? Okay. So moving back to the PDF again. So what does this mean? X, Y uh, commute with each other. That means uh, it is it does not matter if you measure X position first and then Y position. or y position first and then x position. So interchangeability is allowed. As I have already told that A operating on B side is same as B operating on A side. So to keep the discussion simple, it says we consider one-dimensional quantum system, which is represented by the cat psi, and one-dimensional wave function psi x, described in a frame S with its origin at O. Let us see what happens. So what happens if I have the wave function psi in this axis, and it is peaked at x, x is equal to x. So all of you have this concept of group velocity and all. So that means if I'm measuring the position x, then basically the wave function will be picking up at x. And later on, if I am having a bit of translation, then the wave function will move to x plus epsilon x. X plus epsilon x, where epsilon x is the infinitesimal small translation along x direction. So the subscript x is basically defining in the x direction, and epsilon is basically your infinitesimal space translation. So it says here the system is now localized around the point x plus epsilon x. The maximum of the probability distribution is now at x plus epsilon x. Because if you are measuring the position on the wave function psi x, then the wave function will maximize at x. If you are measuring the position at x plus epsilon x, then the wave function will maximize at x plus epsilon x. So that means we have the transformation which is x prime is equal to x plus epsilon x. So we have this translation now. So x prime is equal to x plus epsilon x. This description is known as active transformation, in which the coordinate system remains the same, but the state cat or the physical system is displaced. The coordinate system is remaining fixed, but the system, the wave function or the system, physical system is displaced. This is in contrast to the passive transformation picture, in which the state cat can be assumed to be same and the coordinate system is displaced in the opposite direction. It is like uh, uh, one person standing on the road and another person moving inside a car. So if we look at from the perspective of the person standing on the road, the car is moving in the forward direction. But with respect to the person sitting in the car, the person standing on the road is moving backward. We all have this experience. It is nothing but same thing that if we are keeping our reference frame uh, to be static, it is not moving, then our physical system has to move a small infinitesimal distance epsilon x. Or we can say, well, we are fixed, so the reference frame has to move backward. So if we come back, what happens to our wave function? So the transformed wave function moved from the position x to x plus epsilon x. Now, what happens to psi, the wave function? Psi t, so t represents the transform after the operation, translation one. So psi t at x prime must be equal to psi x. Why? Because under symmetry, the system must remain invariant. System, there should not be any change. There should not be any change in the wave function. That is what we have claimed here. What is symmetry? If you remember, symmetry operation on any system can be defined as an action or same change on the physical system that leaves the system invariant. So system will not change. So here psi t x prime must be equal to psi x. Clear? Is it clear up to this point? Everybody with me? ବୁଝି ହେଉଛି ତ ନା କୋଉଠି କିଛି ପ୍ରୋବ୍ଲେମ ଅଛି?
Yes, sir. Huge.
Good, good. Now, using equation 1.2 and 1.3, so 1.2 is your this one, x prime is equal to x plus epsilon x. 1.3 is this one, psi t x prime is equal to psi x because of the symmetry. Then psi t x plus epsilon x must be equal to psi x, which is equal, this implies psi tx will be equal to, so what do we have? So if we have x plus epsilon x here, we will have x here. If we have x here, that means, so this is the picture where I am looking at this, the reference frame is static and the physical system is moving, the first part. The second part is that the physical system is static and the reference frame is moving in the backward direction. Both are same. So psi t x plus epsilon x equal to psi x. This implies psi t x must be equal to psi x minus epsilon x. This is because of this argument where it says that it is active transformation and this is passive transformation. But overall, it is the same event which we are talking about. So for an infinitesimal small value of epsilon x, for a small infinitesimal value of epsilon x, this psi x minus epsilon x can be represented as psi x. So you can have a series transformation, right? So psi x minus epsilon x will be equal to psi x minus epsilon x del psi by del x plus epsilon x square del square psi by del x square by factorial 2 and all higher order terms, right? So that will continue. But epsilon x is very small. So terms higher in power of epsilon x, that like epsilon x square, epsilon x cube, that will go to 0 because epsilon x is small. So if you are making square, then it will be even smaller. So retaining only the first two terms in the expansion. So we are neglecting this part. Hmm? This part we are neglecting. So then retaining only retaining only the first two terms in the expansion, psi tx will be equal to how much? If we look at here, psi tx will be equal to psi x minus epsilon x. X minus epsilon x is psi x minus epsilon x del psi by del x. So that's what it is done. Take psi x common. So then it will be 1 minus epsilon x del psi by del x. Now this part here is kind of can be written like this. So how exactly? So 1 minus epsilon x del psi by del x. This one I can write simply equal to 1 minus, so I'll multiplying I epsilon x, then another minus I into minus I into minus I is equal to minus I square, which is equal to 1 minus I del psi by del x. So this is equal to 1 minus I epsilon x. So this one minus I del x. Now this is equal to 1 minus I epsilon x kx cap. Is this part clear now? This is this kind of mathematics we'll be using in all three formulations, in translation, rotation, and in case of time translation as well. Is it clear?
जी sir.
Okay, good. So then you are familiar with this kind of operator, right? What is it? Can somebody guess? What is it? Now, if we have a H cross, then it will be familiar, right? So this, you are familiar with this one, the momentum operator, right? So Px cap is equal to minus IH cross del by del x, right? This has already been covered in quantum 1, isn't it?
Yes sir. Yes sir.
Yeah. So Px cap is equal to minus IH cross del by del x. Here I have minus I del by del x. So if I multiply one H cross here, I'll divide one H cross here. So that means my kx over here will be equal to Px by H cross. Px by H cross. So this equation, which I got initially, this one, psi tx is equal to 1 minus I epsilon x kx cap psi x. Now I can write psi tx is equal to 1 minus I epsilon x. Instead of kx, I'll write px cap by h cross, right? Operating on psi x. So you can see epsilon x and px are coming like this. If we have a three-dimensional one, so it is like x component only. So if we have three-dimensional one, then instead of x prime going to x plus epsilon x, well, I'll write r prime vector is transformed to r vector plus epsilon vector, where epsilon is a very small infinitesimal translation in three dimension. So then uh, instead of writing epsilon x px, I would rather write the operator form, in the operator form, p cap dot epsilon vector by h cross. And uh, our p in three dimension, instead of having I minus ih cross del by del x, it will be minus ih cross del operator, where del operator is nothing but I cap del by del x plus j cap del by del y plus k cap del by del z. Okay. So now what happens from translation operator, we just saw that kx, the operator kx, is called the generator of infinitesimal translation along x-axis, because here we are having this psi tx one, this one is psi x, so that is there. The extra change which happened to psi x is minus I epsilon x kx cap psi x. So here kx is kind of operating on psi x, giving rise to this translation from x to x plus epsilon x. So this kx is basically called the generator of infinitesimal small translation along x-axis. Or if we, in that sense, we take p in three dimension, the p vector p cap minus is cross del is the generator for translation in three dimension. So momentum operator in quantum mechanics is therefore proportional to generator of infinitesimal small translation. Is this part clear? That momentum, it is the momentum operator for which we are actually getting this translation from x prime is equal to x plus epsilon x, with the condition that psi transformed at x prime must be equal to psi of x. Now, two different functional form of the wave function, which is psi x and psi tx of the same state psi. So this is pure wave form, but here we are representing it in the form of kate. can also be taken to be the representation of the state psi in two different bases in Hilbert space. Hilbert space already have been taught, right?
No, sir.
No?
We had a bit of this operator, but it was said that operator will be explained in details today, and Hilbert space will be done handled there.
Okay, okay. Let me take only 2 minutes to give a concept of what Hilbert space is. Okay,
Okay, sir.
digressing little bit from what we are discussing. So, in quantum mechanics, we understand that a wave function psi can be expressed as a linear combination of n independent vectors, right? If I try to give a very crude example, I'll give a very crude example which all of you have already studied, maybe in BSc or mathematical physics. That let's say that the position vector can be expressed in terms of. Let me open my video so then I can just a second. So the r vector can be represented as xi cap plus yj cap plus zk cap, right? Now, this is in Cartesian form, right? Now, what about in spherical polar? Can anybody tell me? How do we write? It will be some, okay, if we don't remember, some r cap plus some theta cap plus some phi cap, right? Manipur Chethi, are you able to recall? Vector algebra has been taught already? No? Can anybody confirm? Are able to follow this one or not?
I think it was taught, but I just forgot it, sir. Sorry.
Okay, that's fine. No, see, we are here not to. I mean, let me be very frank. That see, we don't really need to remember everything, but we need to understand everything. That is very important. Okay, so what my point is that if I have a, let's say, a coordinate system x, y, and z, I have a x, y, and z, and I have a vector position vector which is r. Right now, this r can be represented as xi cap plus yj cap plus zk cap. But if instead of x, y, z, if I take a spherical polar coordinate system r, theta, phi, then r vector will be some r cap plus some theta cap plus some phi cap. It is the same r vector, right? We are not changing anything. We are just using a different coordinate system, right? We are just using a different coordinate system. We also have a cylindrical coordinate system, where the r vector will be written as some r cap, then sorry, some r cap plus some you call it or you call it a rho cap, then theta cap, and plus some z cap, like that, rho theta z. So, so the point is, it is the same physical quantity we are measuring, but we are using different coordinate system. So, changing coordinate system will not change the physical quantity. But what is the property of these coordinate systems? That I cap is independent of j cap. I cap and j cap are mutually independent. Anything in I cap direction cannot be expressed in terms of j cap, or anything along j cap direction cannot be expressed in terms of k cap. So they are mutually orthogonal to each other. They are mutually orthogonal to each other. Similarly, the r cap and theta cap and phi cap, all of them are mutually orthogonal to each other. That's why in generally in BSc first semester it is being taught that the spherical, the orthogonal coordinate systems, curvilinear coordinate systems. So these are all orthogonal curvilinear coordinate systems. That means r cap, the quantity in along the r cap direction cannot be expressed in terms of theta cap or phi cap. So similarly, if we take this concept to more than 3 dimension, so a wave function psi x can be expressed in terms of, let's say, psi I, pi I running from 1 to n, right? So where these phi I are the basis vectors in n-dimensional Hilbert space. So n-dimensional space, which is called the Hilbert space. So that means a particular vector can be expressed in terms of n mutually orthogonal vectors. A particular vector in n-dimensional space. We are talking here in I cap, j cap, k cap, or r cap, theta cap, phi cap, or rho, theta, z. We are expressing it in terms of 3 dimension. Instead of 3 dimension, if we have n dimension, then what will happen? That uh, we can express the vector in terms of n mutually orthogonal vectors like I cap, j cap, k cap, and so on and so forth. So that space where a particular vector, so because in Hilbert space this wave function is also a vector, so a wave ket vector, so that ket vector can be expressed in terms of the mutually orthogonal basis vectors. Then you, if you have in 3 dimension, this I cap, j cap, k cap are basically your basis vectors. I cap, j cap, k cap are basically your basis vectors. You, through those basis vectors, you are actually, and x, y, z over here are similar to your ci, the coefficients. Okay, so that way we can explain what is Hilbert space. Now in that, coming back to what we were discussing, uh, uh, so two different forms of wave function, psi x and psi tx of the same state psi, can also be taken to be the representation of the state psi in two different bases, namely psi and psi, x and x prime. So we can write psi of x is equal to x psi of x operating on psi like that, and psi dx is x prime psi. So this is the notation that will be used in Hilbert space. So the problem of transformation of wave function under a space translation is equivalent to the problem of transformation of basis under translation. So let us try to understand this statement. So the problem of transformation of wave functions under space translation. So this is an active translation. Problem of transformation of wave function under space translation. That is an active translation. Is equivalent to the problem of transformation of basis. That means the reference frame under space translation. So it is same as per the argument over here, that this description is known as active transformation, where in which the coordinate system remains same, but the state cat, the physical system is displaced, psi is displaced. But this is in contrast to the passive transformation picture, in which the state cat can be assumed to be the same and the coordinate system is displaced. So here you can imagine like the coordinate system has been displaced, like the basis vectors has been changed. Is this part clear to all of you? Is it clear?
Yes.
Okay.
Yeah, I'll just take 1 minute break. Just take water then. space translation operator. So now let us come to the operator formalism. We start by formally defining a translation operator, which is t cap epsilon x. So what does t cap epsilon x? It is an operator. T cap epsilon x is an operator. What does it do? So t cap epsilon x operating on the state vector x will move it to x plus epsilon x. So t cap epsilon x ये क्या करता है? बेसिकली ये स्टेट जो x स्टेट है उसको x प्लस एप्सिलॉन x स्टेट को ले जाता है. ओके, इज दैट पार्ट क्लियर? So the operator t will take the system from x position x to position x plus epsilon x. Now there could be an arbitrary phase factor which we take it to be unity. We'll come to that part later on when it will e to the power factor will come. We'll see that. A particle in the states x is located at x. When the operator t acts on the state x, it is transformed to x plus epsilon x state. So this is what it means. The equation 1.9, the meaning of that equation is a particle in the state x is located at x. When the operator t acts on the state x, it is transformed to the state x plus epsilon x. A particle is in the state x plus epsilon x is located at x plus epsilon x. So basically, we are representing, this is a way of representing only, that the state vector, we are just, instead of writing psi of x plus epsilon x, we are, instead of writing psi of x, we are writing cat x. Instead of writing psi of x plus epsilon x, we are writing cat x plus epsilon x. To just make the mathematics simpler. Let us look at the effect of translation operator on the arbitrary state psi. Since x forms basis by introducing an identity operator. All of you are familiar with this part? This is an identity operator. This must have been taught in quantum 1. So if not, then just keep it in mind that we can write the identity operator like this. So cat bra integration over dx is basically equal to the identity operator. So we have this equation t epsilon x operating on x cat is equal to x plus epsilon x cat. So same equation here. T epsilon x operating on psi will be equal to what? T epsilon x. Now I'm just multiplying one identity operator. Multiplying or operating with an identity operator will not do any change. Just multiplying with an identity operator will not do any change. So here, this one, yeah. So T epsilon x operating on psi will be giving the T epsilon x, then an identity operator operating on psi. Now once this part is done, what we will do, we'll take this T epsilon x inside the integration. T epsilon x inside the integration. So once we take T epsilon x inside the integration, so T epsilon x will operate on x cat. So I'm taking this T epsilon x inside the integration, so it becomes d integration over dx T epsilon x operating on x cat. T of epsilon x operating on x cat will give x plus epsilon x cat. So x plus epsilon x cat x, then operating on psi. So defining x prime is equal to x plus epsilon x. So this will become x prime, right? X plus epsilon x will become x prime. Now x prime, this will become, x will become what? X prime minus epsilon x. So x prime minus epsilon x operating on psi. dx and dx prime are same. Dx and dx prime are same. If we differentiate, if we take this equation and differentiate on both sides, so dx prime will be equal to dx. So now this equation over here, can be yes. Anybody? Any doubt? Okay. So this equation integration dx x plus epsilon x, this one now can be written like this. So t epsilon x operating on psi x, t epsilon x operating on psi x will be equal to dx prime x cap sorry x prime minus epsilon x psi. Now since in this integration, the integration variable is x prime, so I can simply change the variable to x again. So by because it's a dummy variable, so changing x prime, being a dummy variable, changing to x again, so dx prime will become dx, x prime will become x, and so the equation t epsilon x psi will now become integration dx x minus epsilon x psi cat. So if we use the same definition again, psi of x is equal to x psi bracket, then x transformation or t epsilon x psi will be equal to psi of x minus epsilon x. So this tells us the translated wave function is just the original wave function translated to the right by an amount epsilon x. So when the system is moving from x to x plus epsilon x, so then t operator operating on psi x will give us to psi of x minus epsilon x. So this tells us the translated wave function is just the original wave function translated to the right by an amount epsilon x. Is this part clear? Is this mathematical part clear to everybody? Any doubt?
Okay, sir.
Okay. So the next step is to deduce a form of the translation operator, because till now in this case we only have talked about that the operator t is such form, like a black box form. We don't know what exactly it looks like, but what it does, it takes the system from x to x plus epsilon x. So now the next step is to deduce the form for the translation operator. We ask the translation operator defined have the following property. What? So t minus of epsilon x will basically be the inverse of t epsilon x. What does t epsilon x does? T epsilon x takes the system from x to x plus epsilon x. If I want to move back, so what I will do? I'll take the inverse operation. So that inverse operation is nothing but a translation in the negative direction of x, which is t of minus of epsilon x. To prove this property, let us first consider two successive infinitesimal small translation, which it says epsilon x and alpha. So t epsilon x operating on x, t epsilon x operating on x will take the system to x plus epsilon x. T alpha next. So first we operate with T epsilon x. Next we operate with T alpha. So T alpha operating on x plus epsilon x will take it to x plus epsilon x plus alpha. So therefore T alpha T epsilon will be equal to x plus epsilon x plus alpha, which is again with T alpha plus epsilon x, T alpha plus epsilon x. So now suppose alpha is equal to minus epsilon x, then T minus epsilon x, T epsilon x will be equal to identity. So it is like we are moving in the x direction by a small infinitesimal small amount epsilon x, and then moving back the same amount epsilon x to reach the initial condition, which is basically, so then the operation is nothing but the identity operation. So T minus of epsilon x into T epsilon x will be equal to identity operator. So then in that case, we can simply write, so T minus of epsilon x is basically the inverse of T epsilon x. So this is one property that the transformation or the space translation must have. Next is T epsilon is unitary operator. Unitary operator. So T dag is into T must be equal to identity. T dag into T must be equal to identity. What does it do? So if the system psi is normalized, then psi psi bracket is equal to 1. It is reasonable to impose the condition that the transformed wave function is also normalized, because if you see over here, the wave function itself is not changing much. The wave function, it is only getting transformed from x to x plus epsilon x. So it's a reasonable one. Obviously, we'll later on see that it will smear out. So the width of the wave function will gradually increase, and the height of the probability distribution will decrease. But for a very infinitesimal small translation, it is fair enough to say that it is normalized. Hence, we should have what we should have: the psi T epsilon x dag T epsilon x psi must be equal to 1. Must be equal to 1. I'm not sure if all of you are familiar with this, the quantum 1. Just to remind you. So if I'm taking T psi, I'm taking a dag over here, that will be equal to psi T dag. This is what you need to have. Is this part clear? This one?
Okay, then.
Has it been taught already, or you still are waiting for this? At this point, I'll just try to maybe give a little bit of idea. This handout which is given by IGNOU is a very really concise and pinpointed one. But if anybody interested to read bit of extra for a better understanding, my suggestion are two books. There are thousands of quantum mechanics books, but my suggestion is two books. So if somebody interested can probably write it down. Just maybe just a second. Uh, just one second. One book is by Ajay Ghatak and Loknathan, Quantum Mechanics, Quantum Mechanics Theory and Application. This is a good one for better understanding as well, and bit of worked out examples as well. You can get this book, and the next one would be Quantum Physics by Stefan Gasiorowicz. This is also a very good book, especially for all these discussions on quantum 2. So coming back to, so T, translation operator T must be an unitary operator. So what does unitary operator does? It basically T dag into T must be equal to identity, and here T dag is nothing but the T of minus of epsilon x, because we already have seen that T of minus of epsilon x is T inverse, and T inverse into T is equal to identity, and T dag into T is equal to identity. That means your T dag must be equal to T inverse. T dag must be equal to, that's what we have. And as epsilon goes to 0, this transformation epsilon x will also be equal to identity. What is T of epsilon x? Notice that we have not imposed any particular form for translation operator. We now show that if we choose translation operator for an infinitesimal translation epsilon x of this form, where kx is a Hermitian operator, so kx dag is equal to kx, then it satisfies all the properties listed above. So what we are doing, we first got that translation operator, this translation operator does transform the wave function to x plus epsilon to a to the right by an amount of epsilon x, where the psi can be written as x minus epsilon x, with the property that T of minus of epsilon x is equal to T epsilon x inverse, and it is an unitary operator where T dag T is equal to identity. And from that we also conclude that T dag must be equal to T at my epsilon of minus epsilon of x. So if these are the properties that the translation operator has to satisfy. Now we are claiming that if T can be represented by like this, with K is being an Hermitian operator, that K dag is equal to K, then this T will satisfy all the properties listed here. So we can possibly choose this one. It is not necessary that this is the only one. If we can find another one which will also satisfy, then we can think of. So where kx is an Hermitian operator, so unitary, it has to be unitary. From equation 1.17 we write kx dag is equal to k. So T dag is equal to I. So T dag will be what? I will become minus I, right? All of you know that. I will become minus I. Here I dag will be equal to I dag will be equal to I, and kx dag is equal to kx because we already have chosen Hermitian operator. So T dag epsilon x will be equal to, if I take this definition, it will be I dag minus I will become plus I, then epsilon x is just a small translation amount, then kx cap, which is becomes kx dag, but kx dag will become kx, that's why it is kx here, and so I dag is equal to I plus I epsilon x kx. So what will be T dag into T dag into T will be this one into this one, so I cap plus I epsilon x kx into I cap minus I epsilon x kx, which will give rise to I cap plus epsilon x square and kx square. But epsilon x is very small, right? It's a very small quantity. So epsilon x square will even become smaller. So it will be nearly equal to I, the identity operator. So T dag T will be equal to I. That's what we need, right? T dag T must be equal to I. This is the property that should be satisfied. Now, if we take T in this form and assume that K is Hermitian and epsilon x is very small, then T dag T is equal to I. It satisfies that condition. For any two infinitesimal translation, epsilon x and alpha x, so T alpha x T epsilon x will be equal to T alpha x epsilon x. T alpha x into T epsilon x will be equal to T alpha x plus epsilon x. Okay. This is the property saying that we should have inverse relation over here, so that can be satisfied. Is this part clear up to this point?
Okay, sir.
So we are convinced now that T can form, T operator form can be like this. So identity minus I epsilon x kx, where kx is the generator, right?
Yes, sir.
Okay. All right. So then these parts you can these short questions you already all can try, like T epsilon x. If T operator is in this form, then what will be T dag? You can try to find. We already have seen T dag, and what is T of minus epsilon x will be equal to Tx inverse. These are small. These problems can be solved if you understand this one and this one over here. You will, like the dagger operator. So dagger operator will just so if you take T dag, it will be I dag, then minus I will become plus I, epsilon x is just a number, then kx dag is equal to k dag. Kx dag is equal to k because it is an Hermitian operator. We have chosen like that. So this kind of form, we in the next one also will use this kind of form. So this is very important that this this kind of form of the operator actually satisfies the requirement that has to be satisfied by a translation operator. All right. Yeah. And in three dimension, if I take a three-dimension one, so then instead of epsilon x kx, I will write epsilon vector dot k cap, the three-dimension. Okay, is it clear? We
Yes.
actually worked in one dimension, then we are extending that same argument to three dimension because they are mutually orthogonal coordinate system. Okay. Yeah. So I'll take 2 minutes break. If you have any question, anything, you can ask me. Then I'll start the next part.
Sir, may I have a word, sir?
Yeah, yeah, of course.
Sir, many like me are very, I mean, adult learner. Might be we had our physics in our graduation level after so many years. This opportunity came to us and we just grabbed without knowing much about the thing to happen. And we got admission last July.
Yeah,
Only recently, just couple of days back, we started having the books. Yes, soft copy was there, but we many of us just kept on waiting for hard copy to start with because books are after all books. But that
yeah,
didn't happen. Now, how should we approach the whole courseware? Because it is also very difficult to grasp a 2 hour session covering 4 units or 5 units, and then again reproduce in further learning, higher learning. So I just sir, request you just to give some kind of guidance. How should we approach the whole courseware?
yeah,
Considering we are novice but interested to learn the physics and do good in the exams. Thank you, sir.
yeah. Okay. Anything else? I'll explain. I'll tell that about that. Anything else?
No, this is my currently this is the thing I'm just looking for. I want to do it at this advanced age, but that's it's an opportunity because I had chemistry in my honors
Okay.
during those years. Somehow this opportunity came and just I grabbed. But yes, rightly said, sir, courseware is very fantastically designed. It is up to my ability or inability to grasp it or just stay away. And thank you, sir. for whole Bhubaneswar unit, you are doing marvelous thing for all of us, because I understand it is very tasking, one hard task to have session after session.
Yeah,
Ultimately, gratitude, sir. Yes, sir.
thank you. Um, uh, coming to the very first point of getting all the, I would I would not like, but I would use that word bamboozled everything at the same time. Is it okay if I talk in Odia? Is it fine?
I
Fine,
get
sir.
Yes,
few
Fine.
sir.
words, but not everything, sir. I can
Okay,
catch it.
okay,
आप
I
हम
understand.
बात
I
में
understand.
हिंदी में।
So yeah, हिंदी में बोल रहा हूँ। देखिए, जैसे 5, 7, 8, 10 क्लास में पूरा कोर्स ऐसे पढ़ाएंगे तो खत्म नहीं होगा, बिकॉज
बिल्कुल सर।
ये ऑलमोस्ट लाइक इस 50 to 60 hours लेक्चर्स कोर्स है, ठीक है। So that's why it is not teaching but counseling. The word very much counseling. That it has to be both ways. So you read, and then you take bits and pieces from the lectures, short lectures, and you try to get the idea on your own. And if you have any doubt, any questions, you get back to the teacher or their proper forum where you can write your doubts. Okay. Uh, from learning perspective, I have couple of suggestions that peer learning is very much important. Peer learning is very much important. कि सारे दोस्त बैठ के इसमें ऐसा है कि सारे तो फिजिकली प्रेजेंट है नहीं, है ना। तो
बिल्कुल
हो सकता है कि ओवर गूगल मीट हो या किसी और में आप छोटे छोटे ग्रुप्स में थोड़ा पढ़ाई करेंगे तो किसी का बहुत सारे कॉमन डाउट्स जो है वो क्लियर हो जाते हैं। जैसे मान लो किसी एक पर्सन को एक चीज अच्छे से समझ में आ गया, बट दूसरे पर्सन को वो समझ में नहीं आ रहा है, सो यू कैन गेट इट क्लियर। बट एट द सेम टाइम वो सभी लोग, बुक पढ़ना बहुत इंपॉर्टेंट है। यू मस्ट रीड द बुक। किताब नहीं पढ़ेंगे तो वो नॉलेज कहाँ से आएगा, वो इंफॉर्मेशन कहाँ से आएगा। एक बार, दो बार, तीन बार पढ़ेंगे तभी। क्वांटम मैकेनिक्स इज सच ए सब्जेक्ट, अदर सब्जेक्ट्स भी जैसे मैथमेटिकल फिजिक्स आपको बहुत इंट्यूटिव होना जरूरी नहीं है, बट क्वांटम फिजिक्स में आपको बहुत ज्यादा इंट्यूटिव होना पड़ेगा कि कैसे हो रहा है, क्या हो रहा है ना। एट द सेम टाइम रोबस्ट मैथमेटिकल बैकग्राउंड इज इम्पोर्टेंट। मैथमेटिक्स सब आना चाहिए, तब जाके क्वांटम मैकेनिक्स इजी होगा, है ना। तो
बिल्कुल बिल्कुल।
ऐसा नहीं है कि तो उसमें क्या करना, जैसे मैंने बोला दो बुक्स बोले which I have personally followed during my time. स्टीफन गैसरोविच इज a nicely written book. घटक लोकनाथन का जो किताब है वो भी बहुत अच्छा किताब है। और ऐसा नहीं है जैसे मान लो कि कोई एग्जाम पास करने के लिए ही पढ़ रहे हैं। ऑफ कोर्स एक कोर्स में एडमिशन हुए हैं तो एग्जाम देंगे,
हाँ
तो
हाँ।
ग्रेड्स चाहिए, बट अनटिल अनलेस यू एंजॉय द टॉपिक वो नहीं होगा। सो टू मी कि अगर हम उसको समझने, जस्ट वी नीड टू अंडरस्टैंड। जस्ट अ सेकेंड, पावर कट हो गया है, एक सेकेंड। ऑलराइट, तो थोड़ा थोड़ा उसको इंटरेस्ट दे के पढ़ना है। ऐसा नहीं है कि सिर्फ एग्जाम प्रोस्पेक्टिव से पढ़ना है, बट इंटरेस्ट दे के पढ़ने के बाद जो भी डाउट्स आ रहा है उसको अगर छोटे छोटे ग्रुप्स करके उसको थोड़ा समझने की कोशिश करेंगे तो वो हो जाएगा। और दूसरा है कि बहुत सारे छोटे छोटे एग्जाम्पल्स दिए हुए हैं, जैसे इग्नो के जो पीडीएफ्स हैं, जैसे
चल
मैंने तो उसको प्रिंट करवा लिया। आई थिंक उसमें आप मोबाइल में भी पढ़ सकते हैं, बट आई रेदर प्रिफर ए प्रिंटेड हार्ड कॉपी फॉर माय
बिल्कुल
रीडिंग, बिकॉज आई डोंट रियली लाइक रीडिंग ओवर आवर्स ओवर द लैपटॉप और समथिंग लाइक दैट। तो उससे क्या होता है कि आप थोड़ा स्क्रिबल कर सकते हो, जहां पे डाउट है जो भी है उसको आप उधर ही थोड़ा डाउट करके लिख सकते हो और डिस्कस कर सकते हो। तो उससे बेटर अंडरस्टैंडिंग होगा, उससे बेटर अंडरस्टैंडिंग होगा। और पूरा मटेरियल भी ऐसा नहीं है कि उसको रटना है, उसको बस समझना है, क्योंकि एक बार समझ में आ गया तो वो अच्छे से याद रहेगा। और नहीं समझे हो और सिर्फ इफ यू नो रॉट लर्निंग कर रहे हो, वो कुछ दिनों
वो
बाद
नहीं
तो
होगा, नहीं होगा,
नहीं होगा, है ना।
नहीं
और
होगा।
क्वांटम मैकेनिक्स इज सच कि वो हर जगह चाहिए होगा। बाद में फिजिक्स में हम या केमिस्ट्री में हायर रिसर्च लेवल में जो भी यूज करना है उसमें ये सारे चीजें चाहिए होंगे। अंडरस्टैंडिंग, टू मी अंडरस्टैंडिंग इज मोर इम्पोर्टेंट दिस डेज। ऐसा नहीं है कि याद है तो सब कुछ हो गया, नहीं नहीं। उसको एक इक्वेशन लिखा है, उसका मतलब क्या है वो समझना बहुत इंपॉर्टेंट है ना।
हाँ,
इक्वेशन का फिजिकल मीनिंग क्या हो रहा है, क्या हो रहा है। और बेसिकली अगर सबको ये थोड़ा टाइम बाद ही होगा, बट अगर आप डे टू डे लाइफ में या आपको जो भी अच्छे से समझ, अगर वो मैथमेटिकल कॉन्सेप्ट हो या कोई इंट्यूटिव कॉन्सेप्ट हो, उसको अगर डे टू डे लाइफ इवेंट के साथ कंपेयर करके समझ सकते हैं तो वो अच्छे से याद रहता है। दैट व्हाट आई हैव लर्न फ्रॉम माय टीचर्स एज वेल। कि मान लो कोई भी इवेंट है, उसको हम डे टू डे लाइफ में अराउंड अस कुछ भी देखेंगे, शायद उस तरह कंपैरिजन करके याद रखने की कोशिश करेंगे तो वो अच्छे से याद रहेगा। तो जैसे सिर्फ जैसे मैंने अभी बोला कि ट्रांसलेशन ऑपरेटर ये वो, तो अगर वो उसमें हो क्या रहा है वो समझ में नहीं आ रहा है तो फिर वो मैथमेटिक्स का कोई मतलब नहीं है ना। तो
बिल्कुल।
आई थिंक थोड़ा ग्रुप में पीयर लर्निंग करना, और छोटे छोटे जैसे जैसे पढ़ते जाएंगे छोटे छोटे जो प्रॉब्लम्स हैं उसको करते जाना है। और एक दो, बहुत ज्यादा नहीं पढ़ना, एक दो स्टैंडर्ड बुक्स को तो क्लोजली फॉलो करना है। और आज की डेट में मतलब यूट्यूब वीडियोस अवेलेबल, रेडीली अवेलेबल, थाउजेंड्स ऑफ देम। सो कोई अगर इंफॉर्मेशन चाहिए, इंफॉर्मेशन इज ओवरलोडेड दिस डेज,
हाँ, दैट
इंफॉर्मेशन
इज,
है, बहुत है।
हाँ, बहुत ज्यादा है।
व्हाट वी नीड इज मोर अंडरस्टैंडिंग कि जो लिखा है उसका मतलब क्या है। इंफॉर्मेशन होना बहुत बड़ी बात नहीं है अभी, है ना।
सर, एक सर ये है, QM2 के लिए क्यों QM1 का बैकग्राउंड नॉलेज जरूरी है? व्हाट आई फेल्ट फ्रॉम दिस मॉर्निंग पेपर।
यस।
एंड एक चीज और बताइए, QM एज ए होल क्वांटिटी क्वांटम फिजिक्स के लिए, क्वांटम मैकेनिक्स के लिए मैथमेटिकल फिजिक्स जो है हमारा सेमेस्टर 1 में एक नंबर ये है, उसका उसका प्रायर लर्निंग जरूरत है कि नहीं? कैन यू डू QM स्टैंड अलोन, और दिस हैज टू बी डन विथ मैथमेटिकल फिजिक्स?
नहीं, मैथमेटिकल फिजिक्स में पूरा मैथमेटिकल फिजिक्स कवर होने के बाद क्वांटम पढ़ना है ये जरूरी नहीं है, क्योंकि
थैंक यू सर।
ऑलमोस्ट ऑल यूनिवर्सिटीज इन इंडिया दे आर रनिंग क्वांटम वन एंड मैथमेटिकल फिजिक्स इन द सेम सेमेस्टर, ठीक है ना।
अच्छा अच्छा,
तो
ठीक है सर।
बट क्वांटम टू के लिए मैथमेटिकल फिजिक्स और क्वांटम वन का नॉलेज होना इम्पोर्टेंट है। नहीं तो क्या होगा, थोड़ा सुपरफिशियल लगेगा कि
लगा, हाँ।
पढ़ता रहा हूँ बट मैथमेटिक्स आने के बाद वो समझ में नहीं आ रहा है। बट टू मी आई हैव अनदर सजेशन कि वो क्वांटम वन और मैथमेटिकल फिजिक्स पढ़ भी लिया, वो जरूरी नहीं है सब कुछ याद होगा, ये भी तो है ना।
बिल्कुल
आई
सर।
मीन इट नॉट नेसेसरी कि सारे चीजें दिमाग में होंगे, ये भी तो जरूरी नहीं है। तो उसमें अब क्या करना है, अगर किसी ने पढ़ भी लिया बट जब क्वांटम टू पढ़ रहे हैं कोई भी कॉन्सेप्ट आ रहा है और वो याद नहीं आ रहा, जैसे मैंने अभी बोला कि चलो कोई पोजीशन वेक्टर को आर कैप थीटा कैप फाई कैप में एक्सप्रेस करना है, याद नहीं आ रहा है, ठीक है, अभी याद नहीं रहे वो फाइन है। बट द नेक्स्ट पॉइंट इज कि आज की क्लास खत्म होने के बाद कोई भी मैथमेटिकल फिजिक्स किताब निकाल के मुझे वो एक बार देख लेना है कि वो कैसे लिखा जाता है, सो दैट इट गेट रिफ्रेश्ड। मतलब हमारे दिमाग जो है वो इट इज मोर लाइक रैंडम एक्सेस मेमोरी, ऑल दैट टाइम उसको रिफ्रेश करते रहना है, तब जाके याद रहेगा। क्योंकि इतने सारे चीजें हैं, एकदम से सारे याद रहेंगे और फिर हम करेंगे, ये शायद पॉसिबल नहीं है। तो हमको
नहीं।
जैसे मैथमेटिक क्वांटम टू पढ़ रहे हैं, जो भी मैथमेटिकल कॉन्सेप्ट आ रहा है या क्वांटम वन का कॉन्सेप्ट उसमें रिक्वायरमेंट है, इमिडिएटली उसको उस बुक में जाके या उस मटेरियल में जाके उसको देख लेना है एक बार, सो इट गेट रिफ्रेश्ड, ठीक है ना। और उसको यूज करके फिर हम क्वांटम टू को समझने की कोशिश करना है। इज दैट क्लियर?
Sir, yes, sir. It will be very great guidance.
Yeah,
I
it
was
will
looking
help.
for this
I think it
information.
will help.
Thank you, sir.
But I'm pretty sure that I agree with that, and that's why it is a counseling. It is not a regular lecturing.
Understood,
Uh,
sir.
so so we'll try to cover as much, but it is kind of जैसे बच्चे पहले साइकिल सीखते हैं बाईसाइकिल उनको पहले एक दो दिन तीन दिन पकड़ के
जी नहीं बेटा।
स्टार्टिंग करवाना है और उसके बाद वो खुद चल पड़ेंगे. So our counselor's job is basically to guide you and give the starting kick. So once you get started, you can go on your own. That's not be any problem.
Oh, yes, really, sir. Privilege by भुवनेश्वर रीजनल ऑफिस
Okay,
कहीं पर
thank
तो
you,
हुआ नहीं है, कलकत्ता में नहीं हुआ, आप लोग कर रहे हैं, सो नाइस ऑफ यू सर, थैंक यू सर.
thank you, thank you.
We'll try to
We'll
cover it as much as possible.
Yeah,
Yes, sir.
we'll start.
Okay, sir.
Yeah. So now we saw that if we use K as a generator, or in that for that matter momentum operator as a generator, then we can have our translation from x to x plus epsilon x. So momentum as a translation generator, momentum as a, so kx is basically px by h cross. So if we take this operator, translation operator, as identity minus I epsilon s px by h cross, or in three dimension translation epsilon dot p by h cross, then it will give us that required translation. And so the moral of this part is that momentum is the generator of infinitesimal small translation. And this concept will later on use how symmetry requirements will make the momentum to be conserved. We'll see that. Let us come to the next part, which is rotation. If we have another operator R which rotates the system from xyz to x prime, y prime, and z prime. At this point, should I ask one question? All of you have some knowledge about Euler angles, the transformation. If a system is rotated by an angle theta, how should the Euler matrix look like? Are you familiar with? No? Yes? No?
No, sir.
No. Okay. Let me write down. Later on in classical mechanics, also they will teach, or you can refer your classical mechanics. Paper. So if I have a system, let's say x, y, and z, and if I am making a transformation x prime, y prime, and z prime, then what we have to do is basically use a rotation operator, and that if it is a rotation uh, about z axis, y and angle theta, uh, then what will be this matrix? What will be this matrix? It will be cos theta, uh, sine minus. So we will have this kind of matrix. Uh, so I guess this is minus, this is plus. So that x cos theta minus y sine theta and next one would be x sine theta uh, plus y cos theta, and z prime is equal to z. So try to remember this matrix. ये क्या है? ये मैट्रिक्स क्या करता है? अगर आपके पास एक कोऑर्डिनेट system है x, y, and z, and if you are rotating about z axis, if you are rotating about z axis by an angle theta, तो क्या होगा? Your x कैप का डायरेक्शन चेंज हो जाएगा. मान लो ये इस तरफ आ जाएगा, ये उस तरफ चला जाएगा. सो इफ दिस एंगल इज थीटा, हाँ, सो देन जो वेक्टर है उसका एक्स प्राइम, वाई प्राइम और जेड प्राइम क्या होगा? जेड प्राइम चेंज नहीं होगा क्योंकि जेड डायरेक्शन, जेड एक्सिस के अराउंड रोटेट हो रहा है, तो एक्स प्राइम और वाई प्राइम बेसिकली चेंज हो जाएंगे. सो क्या होंगे? सो दिस इज द मैट्रिक्स cos थीटा माइनस sin थीटा 0, sin थीटा cos थीटा 0, 0 0 1 x y z. So this will basically give you x prime is equal to x cos theta minus y sin theta, y prime is equal to x sin theta plus y cos theta, and z prime is equal to z. Okay. So coordinate axis, the coordinates x, y, z and x prime, y prime, z prime, if once it is rotated, they will be expressed like this. If for small theta, cos theta is 1, sin theta is theta, right? All of us know sin theta is theta and cos theta is 1. So because if you have this series expansion, all of you remember, right? If you have series expansion, so cos theta is 1 minus theta square by factorial 2 plus theta 4 by factorial 4, like that. So if theta is very small, theta square can be neglected. So cos theta becomes 1. Similarly, sin theta, the series expansion is theta minus theta cube by factorial 3 plus theta 5 by theta to the power 5 by factorial 5. So if theta is very small, so theta cube, theta 5 can be neglected, only theta will be there. So sin theta becomes theta, cos theta becomes 1. So if that is the case, so instead of cos theta, will in this equation 1.36, we'll write x 1 y into minus y into theta, and y prime is equal to x into theta plus y, z prime is equal to z. That's what's been written here. So,
सर वन मिनट से वाइल्डर एंगल सर क्या हाउ डू यू प्रोनाउंस सर अभी बताए पहले
which one?
before starting this particular topic you talks about the Wilder angle.
Euler angle. Earlier Euler angles.
U
EU. Maybe I can write it. Euler matrices.
okay sir.
Okay.
Thank you sir.
So x prime becomes equal to x minus y theta, y prime becomes x theta plus y, and z prime becomes z. In that case, the rotated matrix or the transformed matrix psi x prime y prime z prime will be equal to psi x y z, because that's the requirement for symmetry, right? But symmetry is something which will not change our system or invariant. So this means psi r x prime y prime z prime must be equal to psi x prime plus y prime theta, y prime minus x prime theta, z prime. So in that case, so equation 1.38b holds for all x prime, y prime, z prime. So that's why we can just get rid of this dummy variable prime and write it. So psi r will be equal to psi r x y z will be equal to psi x plus y theta, y minus x theta, and z. We are doing very simple mathematics. let me get it very clear that ट्रांसफॉर्मेशन हुआ तो ऐसे इक्वेशन लिख सकते हैं यूजिंग द ऑयलर मैट्रिक्स, और थीटा स्मॉल हुआ तो दैट गेट्स कन्वर्टेड टू दिस वन, एंड देन जो वेव फंक्शन है वो that has to follow invariance. So under symmetry, so that is the symmetry requirement, that psi r x prime y prime z prime must be equal to psi x y z, और psi r x prime y prime z prime को हम in terms of x prime y prime z prime लिखने की कोशिश कर रहे हैं, और बाद में we get rid of the dummy prime and write it in terms of x y z. So psi r x y z becomes equal to psi x plus y theta, y x minus x theta, and z. Now this is a function of three variables, but what happens in uh, what happens in x plus y theta? So we can, since we have a change over in x over here, so we can expand it. How do you look it? Take a partial derivative. So first one would be psi xyz, next one would be y theta, and then all of you following this part? Maybe I go back to the part where we did this, so then it will be much clearer to you. Did it actually? Yeah, over here, you remember? So psi x minus epsilon x is equal to psi x minus epsilon x, then del psi by del x plus higher order terms, right? This part was clear on page number 12. We already have discussed. So similarly, similar part we will be doing over here. Yeah, so it will be y theta, then del psi by del x. Higher order terms will be neglected. From the second one, it will be x theta minus del psi by del y plus higher order terms of theta. So that can be neglected because theta is very small. So what will happen now? Psi xyz. Now if we take theta common, it will be x del psi minus theta common. It will be x del psi by del x minus y del psi by del x. And using same type of formulation again, multiply 1 I and 1 minus I. So in this term, if we multiply 1 I here, we will multiply 1 minus I, because I into minus I is equal to minus I square, which is equal to 1. So it becomes 1 minus I theta into minus ix del psi by del x plus iy del psi by del x. So this operator minus I x del by del y plus iy del by del x, it is called Lz, or the z component of angular momentum operator. Z component of angular momentum operator. As it said, it must have been taught in quantum 1 as well. It is telling. You can check it. Quantum mechanics, आई थिंक क्लासिकल मैकेनिक्स में भी ये थोड़ा बहुत बताया जाएगा जब एंगुलर मोमेंटम के बारे में बोला जाएगा कि एंगुलर मोमेंटम को कैसे एक्सप्रेस करना है. So then also this will come into picture. Okay. So we can see that the z component of angular momentum operator acts as the generator for infinitesimal rotation about z axis. That is very important. वहां पे क्या आ रहा था ट्रांसलेशन के टाइम 1 माइनस आई एप्सिलॉन एक्स के साई एक्स वाई जेड आ रहा था. यहाँ पे क्या आ रहा है साई आर लिया तो इफ वंस वी टेक रोटेशन एज द ऑपरेशन 1 माइनस आई थीटा, वहां पे एप्सिलॉन एक्स क्या था ट्रांसलेशन, द अमाउंट ऑफ ट्रांसलेशन. हियर थीटा इज द अमाउंट ऑफ रोटेशन एंड द जनरेटर क्या है LZ by H cross. LZ by H cross. वहां पे क्या था PX by H cross. So it is kind of comparable. Now for rotation, the operator here, the translation generator is basically अगर z axis के around rotation हो रहा है तो Lz is the generator of that rotation, and Lz is nothing but the angular momentum component, z component of the angular momentum. Is this part clear to all of you?
Yes, sir.
Okay. So, in quantum mechanics, we are interested in deriving a rotation operator, like the translation operator जैसे था, rotation operator कैसा होगा वो भी पता होना चाहिए. The properties of rotation matrices related to geometric rotations are used to deduce some properties of the rotation operator in quantum mechanics. वहाँ पे जैसे translation में क्या हो रहा था वो we discussed that if we move the physical system in the x direction epsilon x and move it back minus epsilon x, it should be identity. यहाँ पे भी कुछ ऑपरेशंस हम कर सकते हैं, बट रोटेशन के लिए जनरली लिटिल बिट ऑफ ग्रुप थियरी इज रिक्वायर्ड. Little bit of group theory is required here. SO2 and SO3 operations will come that will be discussed in detail in mathematical physics and group theory. Okay, so there is no point for me to discuss that, but उसमें क्या है जनरली जो ट्रांसफॉर्मेशन है वो ऐसे एक मैट्रिक्स एलिमेंट की तरह लिखा जाता है. हाँ, you have to write, if you rotated a three-dimensional rotation, then your x prime, y prime, z prime can be written a matrix 3 by 3 matrix into x y z. ये ऑलरेडी मैंने लिखा था अभी. Cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1, that is rotation matrix RZ around z axis, the one parameter group of rotation about axis SO2, जो अगर दो पैरामीटर्स होंगे तो वो SO3 होगा ग्रुप. So according to group theory, so at this point I would suggest when you go through group theory, just try to recall this concept in quantum mechanics. तो वो ग्रुप थियरी में जो भी पढ़ाया जाएगा SO2 SO3, उसका यूज बेसिकली यहाँ पे है जब हम कंजर्वेशन प्रिंसिपल्स और सिमेट्री की बात कर रहे हैं क्वांटम मैकेनिक्स. ठीक है.
और सर ये ऑपरेटर्स का सिग्निफिकेंस क्या है सर? बहुत सारे ऑपरेटर्स है, माने हाउ ये एक सेट ऑफ प्रिंसिपल को रिप्रेजेंट करता है.
ऑपरेटर्स क्या है? इफ यू ट्राई टू एक्सप्लेन दैट, क्वांटम मैकेनिक्स में हम कोई भी फिजिकल स्टेट है उसको हम एक वेक्टर की तरह, जैसे ब्रैकेट नोटेशन में उसको एक वेक्टर की तरह एक्सप्रेस कर सकते हैं. ठीक है. अगर वेक्टर की तरह एक्सप्रेस कर सकते हैं तो वो काइंड ऑफ स्टैटिक इंफॉर्मेशन है. अगर हम उसको मूव करवाना चाहते हैं या उसके ऊपर कुछ मेजरमेंट करके उससे रिजल्ट्स निकालना चाहते हैं, ठीक है, देन वी हैव टू ऑपरेट समथिंग. तो कोई भी अगर पोजीशन वो कहाँ है जानना चाहते हैं तो उसको हम क्या करना है, उसके ऊपर पोजीशन ऑपरेटर को ऑपरेट करने से जो भी रिजल्ट निकलेगा वो बेसिकली विल बी द डिजायर्ड रिजल्ट ऑफ पोजीशन. क्योंकि वो तो वेव है, वो तो हम स्टेट वेक्टर है, तो उससे हम पोजीशन कैसे निकालेंगे, मोमेंटम कैसे निकालेंगे. तो सारे इंफॉर्मेशन उस स्टेट में या वेव फंक्शन में है, बट उसको निकालने के लिए हमको एक ऑपरेशन करना पड़ेगा, उसके ऊपर एक मैथमेटिकल कैलकुलेशंस करना पड़ेगा. वो उस ऑपरेशन को हम ऑपरेटर की तरह, वो फिजिकल क्वांटिटी मोमेंटम निकालना है तो वी हैव टू यूज सर्टेन काइंड ऑफ ऑपरेटर and operate it on the wave vector so that it will give the momentum value. ठीक है. तो सारे फिजिकल क्वांटिटी को हम ऐसे एक एक ऑपरेटर करके लिख सकते हैं. एंड क्वांटम 1 में पढ़ाया जाएगा कि ऑपरेटर्स हर्मिशियन होना जरूरी है, उनका वैल्यू रियल होना जरूरी है, क्योंकि अगर मैं उसके ऊपर ऑपरेट कर रहा हूँ और जो वैल्यू निकल रहा है वो इमेजिनरी है तो फिर मुझे वो रिजल्ट्स कैसे मिलेगा. ठीक है ना. So Hermitian, generally we will be dealing with Hermitian operators most of the time. ठीक है. So जैसे मैंने थोड़ी देर पहले ही बोला है कि हर्मिशियन होना, एडजॉइंट निकलना है या कुछ भी, whatever mathematics we are doing, sometimes we should ask कि इसमें होता क्या है, what exactly is happening. अगर मैं ये ऑपरेट कर रहा हूँ स्टेट वेक्टर के ऊपर तो वो कर क्या रहा है ना. तो तब जाके हमें थोड़ा याद रहेगा कि हाँ, if I make a let's say I take a DAG, so DAG करने से क्या होगा, ये या फिर साई ब्रैकेट करने से उससे क्या निकलता है ना. और दूसरा चीज यहाँ पे मैं थोड़ा स्ट्रेस करूंगा कि मैट्रिक्स एंड डिटर्मिनेंट्स, जो मैथमेटिकल फिजिक्स में मैट्रिक्स फॉर्मुलेशन है, मैट्रिक्स अलजेब्रा, उसको थोड़ा रिफ्रेश कर लेना बेटर होगा, क्योंकि बहुत सारे टाइम हम मैट्रिक्स के ऊपर ही बात करेंगे, है ना. तो कोई भी स्टैंडर्ड मैथमेटिकल फिजिक्स बुक या फिर वो इग्नो का जो मटेरियल दिया गया है उसमें भी मैथमेटिकल फिजिक्स को थोड़ा, जो मैट्रिक्स फॉर्म है, मैट्रिक्स फॉर्मुलेशन, उसका थोड़ा रिफ्रेश कर देना बेटर होगा क्वांटम 2 के लिए.
Thank you, sir.
Yeah. So what exactly is happening here now? Let us look at ये जो r थीटा ट्रांसफॉर्मेशन हुआ है, वहां जैसे टी एप्सिलॉन एक्स था, यहाँ कंपेयर करेंगे r थीटा. ठीक है. और ये अराउंड जेड एक्सिस है, इसीलिए जेड जेड का जो पार्ट है वो 1 है, बाकी एक्स वाई में चेंजेस हुआ है. ठीक है. अब इसको क्या करेंगे, हम इसको हम एक्सपेंड करेंगे, क्योंकि वहां पे तो हमने बोल दिया था कि एप्सिलॉन एक्स को लेना है और हायर ऑर्डर टर्म्स को नेग्लेक्ट कर देना है. तो यहाँ पे हम क्या करेंगे, इस मैट्रिक्स में उस फॉर्म में लिखेंगे. जैसे cos थीटा का एक्सपेंशन क्या है, 1 माइनस थीटा स्क्वायर बाय फैक्टोरियल 2 प्लस थीटा 4 बाय फैक्टोरियल 4. नॉर्मल टेलर एक्सपेंशन जो है वही किया गया है. ठीक है. और साइन थीटा का क्या है, यहाँ पे माइनस नहीं, यहाँ पे सेकेंड रो फर्स्ट कॉलम में साइन थीटा है, सो साइन थीटा इज थीटा माइनस थीटा क्यूब बाय फैक्टोरियल 3 प्लस थीटा 5 बाय फैक्टोरियल 5 एंड सो ऑन सो फोर्थ. यहाँ पे माइनस साइन थीटा, सो लाइक दैट, इफ वी राइट लाइक दैट, तो ये क्या हो रहा है, ये एक इनफाइनाइट डायमेंशनल मैट्रिक्स बन रहा है, क्योंकि यहाँ पे इनफाइनाइट नंबर ऑफ टर्म्स है, यहाँ पे इनफाइनाइट नंबर ऑफ टर्म्स है, यहाँ पे इनफाइनाइट 0 प्लस 0 प्लस 0 वी कैन राइट इनफाइनाइट टाइम्स. तो ऐसे हुआ तो कैसे कैसे करेंगे हम. सो दिस कैन बी रिटन, दिस होल मैट्रिक्स कैन बी रिटन एज आइडेंटिटी मैट्रिक्स. आप देख सकते हैं कि इसमें 1 है, डायगोनल यहाँ पे भी 1 है, यहाँ पे भी 1 है, बाकी सब में अदर देन थीटा जो टर्म है वो 0 है. ऑल ऑफ यू कैन पे अटेंशन कि इस मैट्रिक्स में फर्स्ट टर्म 1 है, इसमें कोई कांस्टेंट टर्म है नहीं, वो 0 है, बिकॉज द टर्म स्टार्ट्स विथ थीटा. उसके नेक्स्ट टर्म में भी वैसा ही है, 0 है. यहाँ पे भी स्टार्ट्स विथ थीटा, देयर इज नो, सो इट्स 0. हियर इट इज 1, हियर इट इज 0, 0 0 1. सो it starts with an identity 1 plus theta into az. Az is a matrix, theta square by factorial 2 into az square. It will keep on going. So this can be expressed as exponential theta az, because this is a series expansion for exponential series, where the matrix az is said to be the generator of infinitesimal rotation. ये जो az मैट्रिक्स होगा, ये क्या करेगा, ये बेसिकली जनरेटर बन गया है, क्योंकि ये जो r थीटा z कैन बी नाउ रिटन एज एक्सपोनेंशियल थीटा az. सो थीटा az is the now generator for making this rotation. अगर z एक्सिस के अराउंड रोटेट कर रहे हैं तो एक्सपोनेंशियल थीटा az हो रहा है. x एक्सिस के अराउंड करेंगे तो if we make rotation around x axis, it will be rx, theta will be exponential theta ax, ry will be exponential theta ay. Okay, so all these will be 3 by 3 matrices. And one thing which we have to remember over here, वहां पे क्या हुआ था कि t एप्सिलॉन x और t अल्फा वो कम्यूट कर रहे थे. मतलब क्या, अगर पहले एप्सिलॉन x ट्रांसलेट किया, उसके बाद अल्फा ट्रांसलेट किया, इट इज सेम एज पहले अल्फा ट्रांसलेट किया और बाद में एप्सिलॉन एक्स ट्रांसलेट किया, दैट इज फाइन. ठीक है. बट यहाँ पे वैसा नहीं है. आर एक्स theta ry phi will not be equal to ry phi rx theta. ये ऑब्वियस है, मैं बताता हूँ कैसे. मान लो पहले सिस्टम को अराउंड एक्स एक्सिस मैंने थीटा रोटेट किया, फिर वाई एक्सिस में फाई रोटेट किया, वाई एक्सिस में फाई रोटेट किया. ये सेम नहीं है कि पहले वाई एक्सिस में फाई रोटेट करके, क्योंकि ऑलरेडी वो रोटेट हो गया होगा, उससे फिर एक्स एक्सिस में थीटा रोटेट करने से वो सेम पॉइंट आएगा नहीं. रादर क्या होगा, मतलब ये आप ट्रांसलेशन करके देख सकते हैं. ये जो ट्रांसलेशन मैट्रिक्स दिया हुआ है, नहीं यहाँ पे नहीं, हाँ यहाँ पे है. मान लो आर जेड थीटा दिया हुआ है, अगर थीटा है तो ये है. फाई कभी हम ऐसे नहीं लिख सकते हैं आर एक्स थीटा आर एक्स फाई. तो आपको क्या करना है, एज ए होमवर्क आप ट्राई कर सकते हैं कि आर एक्स थीटा लिखना है, सो दैट इज रोटेशन अबाउट एक्स एक्सिस बाय एन एंगल थीटा. तो एक्स जो फर्स्ट टर्म होगा वो 1 होगा, बाकी टर्म्स चेंजेस होंगे. आर वाई फाई को लिखना है, फिर उन दोनों को, ये 3/3 मैट्रिक्स होगा, ये 3/3 मैट्रिक्स होगा, इन दोनों को मल्टीप्लाई करना है. यू कैन वेरीफाई कि इन दोनों को मल्टीप्लाई करेंगे और इन दोनों को मल्टीप्लाई करेंगे तो वो सेम नहीं है, इट विल नॉट बी सेम. ओके, so that's why they do not commute with each other. मतलब वो सेम चीज नहीं है, वो बाद में हम देखेंगे. so lx ly will not commute with each other. lx ly operator, because that gives rise to rx will give rise to lx operator, ry gives rise to ly operator. So lx ly minus ly lx will not be equal to 0. That will come back when we talk about the commutation relation. So rotation operator का भी वैसे ही, अगर हम प्रॉपर्टीज स्टडी करेंगे तो वो आर एस टू बी यूनिटरी. ये मैं थोड़ा स्किप कर रहा हूँ क्योंकि यू कैन कंपेयर दिस मैथमेटिक्स, द वन आई एक्सप्लेन विद ट्रांसलेशन के साथ उसको कंपेयर करेंगे तो ये सिमिलर है, क्योंकि वो यूनिटरी होना जरूरी है. A set of rotation operators R form representation rotation group, वो एक ग्रुप फॉर्म करेंगे. ठीक है, so R into I will become R inverse will be I, and rotation will be associated. So in that case, coming back to this equation over here.
सर वो बहुत सारे डेरिवेटिव में कहीं कहीं पे स्टेप जम किया हुआ है. ऑब्वियसली स्पेस इज अ कांस्टेंट, तो उस सब जगह में थोड़ा तकलीफ हो रहा है. तो हाउ कैन वी डील दैट?
Could you repeat again?
Sir, in somewhere in the while forming the derivatives,
Yeah.
there is issues like step jumping in the whatever इग्नो का जो कोर्सवेयर है उसमें. जैसे अभी आप ऊपर ये मैट्रिक्स दिखा रहे थे, तो ऑल ऑफ अ सडन वो अभी एक्सप्लेन किए तो समझ में आया, लेकिन अदरवाइज जब देख रहे हैं तो वो रिलेवेंस नहीं समझ में आ रहा है. तो ये कैसे हम देखेंगे?
वो अब मतलब मैं इसलिए when I could have used other books or my notes to, but I rather prefer this one because this is the one you will be reading, right? So अगर कुछ doubts है, we can try to understand that should not be an issue. कि अगर स्टेप जंप हुआ है तो वो उसमें क्या स्टेप्स होना चाहिए था वो हम डिस्कस कर सकते हैं.
आप ऊपर में दिखाए अभी जो मैट्रिक्स दिखा रहे थे, ऊपर जाइए थोड़ा, अब और ऊपर से, हाँ यहाँ पर ये जो इस जगह जो आप दिखा रहे थे मैट्रिक्स के, और नीचे से जाइए सर, नीचे नहीं, नेक्स्ट. हाँ सर, यहाँ पर यहाँ पर जो दिखाया, यहाँ से ऐसे समझ में नहीं आ रहा, लेकिन आप जब वो एक्सप्लेन किए कि इस तरह का ये सीरीज बन रहा है, तो वी कैन फिगर आउट. So
I mean,
1.4
that's the basic purpose of counseling. So that's not an. तो मैंने जैसे बोला है ना कि आप लोग थोड़ा हो सकता है आप में से कोई एक दो लोग हो सकते हैं कि वो लोग ये पिक पहले से ही पिक किए होंगे कि ये तो सीरीज है ना. तो ऐसे मतलब डिस्टेंस लर्निंग में ये एक बेनिफिट भी है कि आप थोड़ा ग्रुप बना के, थोड़ा आजकल तो व्हाट्सएप हो गया है या दूसरे फॉर्म्स भी हैं, तो उसमें क्या हो रहा है कि किसी को अगर समझ में आ रहा है वो एक्सप्लेन करेंगे तो वो ओवरऑल नॉलेज शेयर हो जाता है ना. अदरवाइज मैं जब एटलीस्ट इन माय पार्ट आई विल ट्राई टू मेंशन कि वो कहाँ पे कितना हो रहा है ना, वो चेंजेस क्या हो रहा है, स्टेप्स कहाँ पे चेंज हो रहे हैं, वो मैं बता देता
ठीक है सर, थैंक यू सर।
हूँ. तो एक चीज अगर नोटिस करेंगे कि ये जो रोटेशन ऑपरेटर है वहां पे क्या था ट्रांसलेशन में, याद आ रहे, आई आई आइडेंटिटी मैट्रिक्स माइनस आई एप्सिलॉन के, राइट, आई एप्सिलॉन के आ रहा था, है ना. तो रोटेशन में क्या आ रहा है, आई माइनस आई फाई के, और के क्या है, वहां पे पी एक्स वाई एच क्रॉस था या पी वाई एच क्रॉस था, यहाँ पे एल डॉट एन बाई एच क्रॉस होगा, वेर एल इज द, एल डॉट एन क्यों है, क्योंकि यहाँ पे एल एक्स एल वाई एल जेड 3 है और रोटेशन किस एक्सिस के अराउंड हो रहा है वो इंपॉर्टेंट है. एक्सिस ऑफ रोटेशन इज इंपॉर्टेंट. वहां पे जैसे ट्रांसलेशन डायरेक्शन इंपॉर्टेंट था, या एक्सिस ऑफ रोटेशन इंपॉर्टेंट है, इसलिए वो एल डॉट इन कैप, मतलब अगर जेड है तो जेड कैप रहेगा, अगर वाई है तो वाई कैप रहेगा, अगर एक्स है तो एक्स कैप रहेगा, और वेक्टर को डॉट एक्स कैप करेंगे तो वो कंपोनेंट निकल के आएगा, है ना. सो ए नॉर्मल ट्रांस रोटेशन, नॉर्मल रोटेशन वो जनरेट हो सकता है किसके थ्रू, एंगुलर मोमेंटम के थ्रू. सो ट्रांसलेशन इज जनरेटेड थ्रू momentum vector and rotation is generated through angular momentum vector और angular momentum operator. ये पार्ट क्लियर हुआ है सबको?
Okay.
Yeah. Then I would suggest all of you, maybe it's probably time now, but I would suggest next class I will talk a little bit on time translation and then conservation principles. So before going into conservation principles, अगर आप लोग थोड़ा इसमें आज देख लेंगे कि मैथमेटिक्स क्या किया गया है, so then conservation principles को हम इजीली समझ सकते हैं, क्योंकि जैसे बहुत सारे टाइम ऐसे हुआ है कि मोमेंटम हैज टू बी कंजर्व्ड, एंगुलर मोमेंटम हैज टू बी कंजर्व्ड, एनर्जी हैज टू बी कंजर्व. बेसिक क्वेश्चन कम्स कि भाई कंजर्व क्यों होना है, ये जरूरी है क्या कंजर्व होना, है ना. वन कैन आस्क कि क्यों कंजर्व होना है, एंगुलर मोमेंटम क्यों कंजर्व होना है. तो उसके आंसर हम ये बताएंगे कि अगर कोई ऑब्जेक्ट एक जगह से दूसरी जगह ट्रांसलेट होता है तो या फेनोमेनन सिस्टम ट्रांसलेट होता है, क्या वो चेंज हो जाता है, नहीं हो रहा है. अगर होमोजेनिटी है, अगर वो सिस्टम चेंज नहीं हो रहा है और वो ट्रांसलेशन किसके वजह से हो रहा है, बिकॉज ऑफ मोमेंटम, तो मोमेंटम को कंजर्व होना पड़ेगा फ्रॉम मैथमेटिकल पॉइंट ऑफ व्यू. ठीक है. तो जनरेटर एक बार हमें ये समझ में आ गया कि ट्रांसलेशन के लिए जनरेटर लिनियर मोमेंटम है और रोटेशन के लिए एंगुलर मोमेंटम है और टाइम ट्रांसलेशन के लिए हैमिल्टोनियन है, बेसिकली हैमिल्टोनियन ऑपरेटर आएगा. तो ये तीनों क्वांटिटी कंजर्व होना जरूरी है अगर हम सिमेट्री के पर्सपेक्टिव से देखेंगे. ठीक है.
जी सर.
Okay, I'll possibly stop it here. And next class, I'm a bit slow, I know, but it is important that I give the starting kick so that ये एक बार समझ में आ गया तो बाद की चीजें आप इजीली समझ सकते हैं.
So it is rather helping us, sir. Too much of information overloading is a problem. It is helping us. Thank
Yeah.
you.
So but इस quantum 2 में the most interesting part would be WKB approximations and perturbation theory, which possibly I will discuss next week. हाँ? ये थोड़ा आप मतलब फॉर द फार साइड ध्यान में रखिए कि ये सब तो मैं समझ लूंगा, ठीक है, लेकिन अगर हैमिल्टोनियन थोड़ा चेंज हो रहा है सिस्टम, क्योंकि वी लिव इन ए रियल वर्ल्ड, वी डू नॉट लिव इन ए आइडियल वर्ल्ड, कि अभी तक क्वांटम 1 में जो भी प्रॉब्लम समझाया गया होगा वो सब आइडियल वर्ल्ड की तरह, सब वन डायमेंशनल प्रॉब्लम आइडियल है. ठीक है. अगर हम रियल वर्ल्ड को जाएंगे, थोड़ा चेंजेस हो रहा है, ग्रेजुअल चेंजेस हो रहा है, तो क्वांटम मैकेनिक्स में उसको सॉल्व कैसे करना है, बेसिकली एनर्जी आइगन वैल्यू, अगर मैं उस सिस्टम के ऊपर मेजरमेंट करना चाहता हूं तो एनर्जी का वैल्यू कैसे निकालूंगा, वो बेसिकली एम ऑफ दिस पार्ट वुड बी. ओके. Okay. Any other doubt you can ask, or we will close maybe?
Thank you, Dr. Saroj Kumar Patra, the academic counselor who has taken this advanced quantum mechanics, that is quantum mechanics 2 class. You all might have known about Dr. Patra. He belongs to the land of Professor J.C. Patti, the greatest scientist of our time, and Dr. Ajit Kumar Mahanti, currently chairman of Atomic Energy Commission and Secretary Department of Atomic Energy. He has done his MSc from Utkal University, Bhubaneswar. Then he has done his MTech from IIT Kharagpur. So he is the best topper at IIT Kharagpur, and then he joined Norwegian University of Science and Technology, Norway, and done his PhD in the field semiconductor nanotechnology. And after that, he has joined as assistant professor at MPC Autonomous College, Baripada, in the year 2018. So he has expertise in antimonide-based mid-infrared laser structures, growth and characterization, and it is in the field of electronics and telecommunication. So thank you, Dr. Patra, for your very nice lecture, and you have made people engaged in these 2 hours and illuminate them with your knowledge and wisdom. Thank you, Dr. Patra.
Thank you.
So thank you all the participants. Next
Thank you,
class
sir.
is tomorrow at 9 a.m. by Dr. Saroj Patra. Saroj Kumar Patra. Okay, thank you.
Thank you, sir. Thank you, sir.